Greetings, M Squared here, and we're going to continue our talk about multiplying binomials. But today we have some special cases. So I'm just going to have you multiply these things. We're going to do it together, and then I'm going to ask you to think about what do you notice and what do you wonder. So there were three different ways that I gave you to multiply binomials. I'm going to choose to use the FOIL method, which is I first multiply the first ones, x times in each term, x squared. So that's these two. Then I distribute, it's kind of like distributive property twice. Then I'm going to multiply 7 times x, so that's 7x. Then I'm going to do the inside ones, that's negative 7x. And then the last ones in each one are negative 49. So I notice that these are like terms, and I know that 7x minus 7x is 0, so I end up with x squared minus 49. Okay, I'm going to try these ones. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is positive 10x. 5 times negative 5 is negative 25. Let me zoom out a little. Okay, the next one, 4 times 4 is 16. 4 times x is 4x. Negative x times 4 is negative 4x. Negative x times x is negative x squared. Oh, I forgot to combine like terms here. Sorry. That's a big 0, so I end up with 4x squared minus 25. That's a big 0, so I end up with 16 minus x squared. And the last one before we notice and wonder, 3x times 3x is 9x squared. Then I get a 30x and a negative 30x, and then a minus 100. Big 0 there because 30x minus 30x is 0. 9x squared minus 100. So now I want you to just look at what we started with, look at our answers, and see if you notice or wonder anything. So what I notice is, hope you can pause and notice and wonder for a minute and then come back if you want. So what I notice is that it's really similar what's inside both parentheses. The difference is just the the minus sign and the positive sign, so the minus plus. So I have x, 7, 7, and then one has a minus sign, one has a positive sign. That happened here. I have 2x plus 5, then I have 2x minus 5. Happened here. 4 minus x, 4 plus x. And over here, 3x minus 10, 3x plus 10. So the order, sometimes the minus sign was first, sometimes the plus sign was first, but the order always happened that way, where I had the same thing one time it was added and one time it was subtracted. So that's one of the things I noticed. I also noticed that in my answer, when I was doing it, that the middle terms always canceled out, because one time I got a positive and one time I got a negative, because when I'm multiplying the same thing, but one time it's negative and one time it's positive, that's what happens. So it canceled out. So the middle terms always cancel out, so I wasn't left with that middle term. And then I noticed that I always ended up with a difference as an answer. So that's a minus sign. They're all minus signs. Well, the other thing I noticed is that I see a lot of perfect squares. That's an x squared, that's a 7 squared, that's a 2 squared, x squared, 5 squared, 10 squared, 3 squared, 4 squared. So I see a lot of perfect squares. So I'm wondering then what would happen if I did this with any other thing. If I always had that plus and minus thing going on with the same exact numbers, would this always happen? And the answer is yes. It always happens. Do I need to know that to successfully complete this? No, I just did it using FOIL. If I noticed it, would it help me? Yeah, it would help you, because if you notice that that's always going to happen, you see the same exact thing, but one's you're adding and one you're subtracting, then you might avoid doing the middle terms because they're just going to cancel out, and you could just say, hey, what's that squared? And what's that squared? Put a minus sign between, because remember, they were all minus. So in class, I'm going to ask you to create your own, but let's say I wanted 3x minus 7 times 3x plus 7, right? One time I'm adding, one time I'm adding, one time I'm subtracting. Well, I could do FOIL, or I can remember, hey, that's always going to be a difference of whatever this guy was times itself, which is squared, times whatever this guy is times itself, or squared. So that's the answer. What if I had 5x minus, let's say 4 and 5x. Well, we'll do that one plus and that one minus, just so you see the difference. So 5x plus 4, 5x minus 4, same numbers, one I'm adding, one I'm subtracting. Okay, so that fits our pattern. Well, 5x times 5x, or 5x squared, is 25x squared. And then 4 times 4 is 16. So if you notice that pattern, it might save you some time, but you can still get it right without noticing that pattern. That pattern is called the difference of squares, the difference of perfect squares, because you see it's the difference of two things that are squares. Okay, on to a different thing that I want you to kind of think about. What is 3 plus 2 squared? How would I do 3 plus 2 squared? Well, order of operations says I always do what's inside the parentheses first. So what is 3 plus 5? 3 plus 2, it's 5, and 5 squared is 25. And what is 11 minus 4 squared? Well, I have to subtract first. 11 minus 4 is 7, so I'd square it, and that is 49. So when we get to a problem like this, people get confused because they say, oh, I can't do that. So what they end up doing is actually squaring both of those. But let me show you why that's wrong. If we had done that up above, if we had said 3 squared plus 2 squared, we would have gotten 9 plus 4. 9 plus 4 is not 25. This is a no-no. Order of operations only works if you follow it, and this is not following order of operations. So you cannot do that there. This is a subtraction sign. If it was multiplication sign, those have different rules, right? We could have done that, but this is a subtraction sign. So we always have to remember what squared means. Just like up here, squared means 3 plus 2 times 3 plus 2. That's 5 times 5, which is 25. So here, it means x minus 3 times x minus 3. Well, then that's a different way to do that, right? Then I use my FOIL. X times x is x squared. I get a negative 3x and another negative 3x. And then negative 3 times negative 3 is a positive 9. Like terms, so I get x squared. These do not cancel out because they're both minus, so I get that. So notice it was one binomial squared. You must write it like this, or you're going to get it wrong. So you got to make sure you do that. So x times x is x squared. X plus 2 is x plus 2 times x plus 2. That's super important to remember. Okay, so we're going to do a couple of those. So x plus 3 times x plus 3. We did the difference up there. That's what this means. So I'm going to get x squared plus 3x plus 3x plus 9. And when I combine the middle terms, this is what I get. Okay. Let's try this one. So I write it as this binomial times itself because that's what squared means. And then I use my FOIL. So x times x is x squared minus 7x for my outers and inners, and then plus 49. X squared minus 14x plus 49. Whoops, 49. Okay, so let's try this one. 3x minus 5 times 3x minus 5. So 3x times 3x is 9x squared. 3x times a negative 5 is negative 15x. And then we have another negative 5 times 3x, which is another 15x. And then negative 5 times negative 5 is 25. Those two combine. 9x squared minus 30x plus 25. So for the observant person who likes shortcuts, I'm going to show you something. Let's observe what happened. It's always a binomial squared, right? That's the pattern I'm looking at. Well, what happened? This is x squared, which is that guy squared. This right here is that one squared. And then how did this number come about? Look, 6 was 2 3s, 14 was 2 7s, 30 was 2 15s. How did I get that 15? Well, it was 3 times 5. How did I get that 3? It was 1 times, it was x times 3. It was 3x times 5. It was x times negative 7 got me my negative 14. So there is a kind of a shortcut. So I can say, oh, well, the pattern is whatever this is squared. Remember, it's still 2x plus 9 times 2x plus 9. But I'm just noticing a pattern. And if you notice patterns in math, it kind of makes figuring things out easier. So if I square that one, that's 4x squared. If I square this one, that's 81. And what went in the middle was the product of those two. So what's 2x plus 9? It's 18. And what's and then there would be two of them, right? There'd be an 18x there and an 18x there, which would get me a 36x. And so that's another way to do it, is just to notice that pattern and what's happening every time you do that, and it kind of makes things easier. But again, you don't have to do it. You can use FOIL too. Okay, good. M squared, signing out.